Have you ever stopped to think about the unsung hero that's working right now to keep your home comfortable? Well, in this explainer, we're going to pull back the curtain on the amazing engineering that keeps you cool when it's hot and warm when it's not. The Scroll Compressor.
Seriously, think about your AC for a sec. You've got fans, you've got filters, all that stuff. But what's the one part that's doing all the real work? What's the powerhouse of the whole system?
You got it. It's the compressor. This is the absolute workhorse inside your air conditioner and your heat pump. It's what moves the refrigerant around and creates the pressure that makes the magic of heating and cooling actually happen.
But here's the thing. Not all compressors are built the same. For decades, the old-school piston model on the right was pretty much all you could get. But today, we're talking about the sleek, super-efficient scroll design on the left. This is really a story about how a new challenger completely changed the game.
All right, so here's our game plan. We're going to start with a little history, the tale of two compressors. Then we'll peek inside the scroll to see exactly how it works. We'll put it head-to-head with the old piston design, see why fewer parts mean better performance, talk about the real-world benefits, and then wrap up with some key info for the technicians out there. Let's do it.
So for more than 30 years, piston compressors were king. They were the reliable, go-to technology in the air conditioning world, chugging away in millions and millions of homes. They just worked. But, things started to change.
People just started expecting more. Energy costs were going up, so efficiency became a huge deal. And homeowners didn't just want their houses to be cool, they wanted them to be quiet, to be more comfortable. The stage was set. The market was practically begging for a better idea. Okay, now for the really cool part. Let's get right inside this thing and see what makes it tick. The engineering is, well, it's just so elegant. It's one of those ideas that's so simple, you'll wonder why nobody thought of it sooner. Okay, picture this. Imagine you have two paper plates, and you draw an identical spiral on each one. Now, you flip one over and fit it inside the other. If you hold one plate still and just kind of orbit the other one around in a little circle, you'd see these pockets form that trap air and push it toward the middle. That is exactly what's happening inside a scroll compressor, just with refrigerant gas instead of air. And this diagram really shows that process perfectly. See how the gas gets pulled into those big pockets on the outside? As that one scroll orbits, it seals those pockets off, and they get smaller and smaller as they're pushed toward the center. Let's walk right through it. So gas gets sucked in. The orbiting scroll moves and seals that pocket. Then, as it continues its orbit, that pocket gets squeezed smaller and smaller, which naturally increases the pressure. Finally, when it hits the very center, it's fully compressed and shoots out of a little port. See? It's this smooth, constant motion, not that choppy up and down banging of a piston. So, how does this brilliant design actually translate into being, well, better? The secret, my friends, is in its simplicity. This is where you'll see the biggest, most shocking difference between the old way and the new way. Think about this. For a standard piston compressor to do its job, it needs about 15 different moving parts all working together in perfect harmony. You've got valves, rods, seals, all kinds of things that can wear out or break. And then you have the scroll. It does the exact same job, but it throws all that complexity out the window. It basically has just two major components, the fixed scroll and the orbiting scroll. That's it. Pretty incredible, right?
So here's the bottom line. Fewer moving parts means fewer things can go wrong. It's just a more reliable design, period. Plus, because of the way the scroll works, the pressures inside are balanced, which means it doesn't need a huge jolt of power to get started. It's just more efficient from the absolute get-go.
Okay, so we've established it's simpler and way more reliable. But what does that actually mean for you, for your house, for your electricity bill? Let's take a look at the real-world impact of this fantastic design. When it comes right down to it, a scroll compressor is at least 10% more energy efficient than your standard piston compressor. That smooth, continuous compression means no wasted energy, and that translates directly into lower energy bills for you month after month.
And your ears will definitely notice the difference, because there's no clanking piston, that noisy vibration and pulsing sound is just gone. And 5 decibels? Trust me, that's a huge drop in sound. It's the difference between a loud hum and a quiet whoosh.
Oh, and this thing is tough. It's built like a tank. It can handle things like liquid refrigerant getting back into it, which would absolutely destroy a piston compressor. It can even handle a little bit of debris in the system. And like we said, with just 2 main parts doing all the work, you're going to be making a lot fewer calls for repairs.
All right, let's shift gears for a minute. For all you technicians and HVAC pros watching, this beautiful design comes with its own special set of rules.
It's a fantastic piece of tech, but you have to know how to handle it.
And this is absolutely critical. Even though scroll compressors are incredibly durable, there is one single thing you can do during service that can cause a total, catastrophic failure.
And there it is, in all caps, for a very, very good reason. If you try to run a test on this thing with the suction valve closed, it'll pull a super deep vacuum. That can cause electrical sparks inside the compressor itself, and poof, you've got a very expensive paperweight. It's a costly and totally avoidable mistake.
Even the installation requires a special touch. When you're brazing the copper suction tube, you can't just blast it with heat wherever you want. There's a very specific procedure you have to follow to protect all those delicate internal parts. You gotta follow these steps to the letter. You start by heating the tube a bit further away from the compressor, then you move closer to get the fitting hot enough, and then you move right to the joint to pull that braze material in for a perfect seal. If you overheat it, you can cause some serious damage.
So, there you have it, the scroll compressor. It's a perfect example of truly brilliant engineering that's hiding in plain sight. It's more efficient, it's way quieter, and it's a whole lot more reliable than the technology it replaced. It's one of those innovations that just quietly made life better for millions of us. And you know, it kind of makes you wonder, what's the next big idea that's out there, waiting to do the same thing?